Okay, so in the last video we did recursive formulas. Now we're going to do explicit formulas. And so sometimes you can find the value of a term in a sequence without knowing the previous term. So instead you can know the number of the term to calculate its value. So an explicit sequence is just a formula based on the number of the term. And again, we have a real life example for you to hopefully look at and understand what I'm talking about. So if we have this square here, and I tell you that the length of the side is 1 unit, then the perimeter would just be me adding up all 4 sides. And so that would be 1 plus 1 plus 1 plus 1, 1 plus 1, 4. So the perimeter would be 4. So if the length of your side changes to 2, then 2 plus 2 plus 2 plus 2 would be 2 plus 2 plus 2 plus 2, 2, 4, 6, 8 would be 8. If you change it to 3, that would be 12. If you change it to 4, that would be 16. 5 would be 20. 6 would be 24. And then n, if you didn't know the number of the sides, then the length of the side would be n. And so what did we do to get from 1 to 4, from 2 to 8, 3 to 12, 4 to 16? So all we're doing, if you look at these numbers, is just multiplying by 4. So I'm going to take 4 and just multiply it by whatever the number of the length of the side is. Okay, so if we found A7, I would just say this is going to equal 7 times 4, which is 28. And then 25 would be 25 times 4, which is 100. And so then this would represent an explicit type of problem because our terms here are not based on the term before. So given this following sequence, we want to write an explicit formula and then use the formula to find A11. Now, in an explicit formula, it's not like a recursive where you have to tell me what A1 is. You don't have to do that. It doesn't matter. This explicit sequence is based on the number of the term itself. So I'm going to make this bigger. And I'm going to label above it. This is 1, 2, 3, 4, 5, 6. So those are my terms, the 1 through 6, and then these are the actual numbers that they are. So I'm going to look and see what can I do to get from 1 to 1. What can I do to get from 2 to 4? What can I do to get from 3 to 9, 4 to 16, 5 to 25, and 6 to 36? And so AN, any number of a term that I'm looking for, is just going to be, if you look at this, you can see that if I take these numbers of the terms and square them, I get the term. So I'm just going to take whatever n is and square it, and that's going to be my explicit formula. And so then A11 would just be 11 squared, which is 121. All right, we have one more example of an explicit formula, and I hope this is easy, but I'm just going to number this. 1, 2, 3, 4, 5. And so I'm looking for a way to get from here to here. Now I'm going to show you a trick or an easy way to do it that will sometimes work. So AN, any term, I need to find a way to get from 1 to 2. Well, if I think 1 plus 1 gives me 2, but 2 plus 1 does not give me 5. So there's another pattern going on here. And so an easy way to go about doing this is the number, if these numbers down here increase by the same amount each time, and they do, so 2 plus 3 would give me 5, 5 plus 3 would give me 8, 8 plus 3 would give me 11. So these are increasing by 3. Whatever this number is, that is the number that is going to go in front of n, okay, in an explicit formula. And so if I use what I have so far, 3n, 1 times 3 would give me 3, and I would have to subtract 1 to get to 2. And so then I'm going to check this to make sure it works for all of them, and it should. 2 times 3 gives me 6, minus 1 gives me 5. 3 times 3 gives me 9, minus 1 would give me 8. So this is going to work for this sequence. And so that would be my explicit formula. A15, I would do 3 times 15, which would be 45. 45 minus 1 would give me 44. Right, I don't have any more examples. I think I'll do one more, though, just to hopefully make it a little easier to see. So we want to write an explicit formula. I'm going to do one that is a negative. So let's go negative 2, negative 12, negative 22, negative 32. All right, so I want to write an explicit formula for this sequence. And so this is my first term, second term, third term, fourth term. So I'm going to come down here and do AN. And so I'm going to find what the pattern is between these numbers. And this one's easy to see, that all I'm doing each time is subtracting 10. And so if I'm subtracting 10, remember, the number that it's going up or down by is the number that goes in front of n, so negative 10n. And so then I'm going to look and see what I could do. If I plug in 1, negative 10 times 1 would give me negative 10. What would I have to do to get to negative 2? If I'm at negative 10 and I want to get to negative 2, I would have to add 8 to that. So then we can look and see if that's going to work for the rest of them. 2 times negative 10 would be negative 20, plus 8 would give me negative 12. 3 times 10, negative 30, plus 8 would give me negative 22. So this one will work. And so to write recursive and explicit, that's how you're going to do it. In the next video, in part 3, I'm going to show you how you can go back and forth and interchange and write a recursive and an explicit for any given sequence. So one more video after this one, and we'll be done with these intro to sequences.